Logistic regression. What is logistic regression? Logistic regression is a machine learning method that is used to solve classification issues. It is a predictive analytic technique that is based on the probability idea. The classification algorithm logistic regression is used to predict the likelihood of a categorical dependent variable. The dependent variable in logistic regression is a binary variable with data coded as 1, yes, true, normal, success, etc., or 0, no, false, abnormal, failure, etc. The goal of logistic regression is to discover a link between characteristics and the likelihood of a specific outcome. For example, when predicting whether a student passes or fails an exam, based on the number of hours spent studying, the response variable has two values, pass and fail. A logistic regression model is similar to a linear regression model, except that the logistic regression utilizes a more sophisticated cost function, which is known as the sigmoid function, or logistic function, instead of a linear function. Many people may have a question, whether logistic regression is a classification or regression category. The logistic regression hypothesis suggests that the cost function be limited to a value between 0 and 1. As a result, linear functions fail to describe it, since it might have a value larger than 1, or less than 0, which is impossible according to the logistic regression hypothesis. Logistic regression equation. The sigmoid function is a mathematical function used to map the predicted values to probabilities. It maps any real value into another value within a range of 0 and 1. The value of the logistic regression must be between 0 and 1, which cannot go beyond this limit, so it forms a curve like the S-form. The S-form curve is called the sigmoid function, or the logistic function. In logistic regression, we use the concept of the threshold value, which defines the probability of either 0 or 1. Such as values above the threshold value tends to 1, and a value below the threshold values tends to 0. Types of logistic regression. In general, it can be classified into 1. Binary logistic regression, 2 or binary outcomes like yes or no. 2. Multinomial logistic regression, 3 or more outcomes like first, second, and third class, or no class degree 3. Ordinal logistic regression, 3 or more like multinomial logistic regression, but here with the order like customer rating in the supermarket from 1 to 5. Requirements for logistic regression to work well. This model can work for all the datasets, but still, if you need good performance, then there will be some assumptions to consider. 1. The dependent variable in binary logistic regression must be binary. 2. Only the variables that are relevant should be included. 3. The independent variables must be unrelated to one another. That is, there should be minimal or no multicollinearity in the model. 4. The log chances are proportional to the independent variables. 5. Large sample sizes are required for logistic regression. Decision boundary. Logistic regression. A threshold can be established to forecast which class a data belongs to. The derived estimated probability is categorized into classes based on this threshold. If the predicted value is less than 0.5, categorize the particular student as a pass, otherwise, label it as a fail. There are two types of decision boundaries, linear and nonlinear. To provide a complicated decision boundary, the polynomial order can be raised. Logistic regression cost function. Instead of mean squared error, we use a cost function called cross-entropy, also known as log loss. Cross-entropy loss can be divided into two separate cost functions, one for y equals 1 and one for y equals 0. Minimizing cost using gradient descent. To minimize our cost, we use gradient descent just like before in linear regression. There are other more sophisticated optimization algorithms out there, such as conjugate gradient like BFGS, but you don't have to worry about these. Machine learning libraries like scikit-learn hide their implementations so you can focus on more interesting things.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.